Dear friends, welcome to another very exciting edition of Data Science Tutorials. Myself, Dr. Suptik Mukherjee. Today's topic is plotting using Matplotlib. But before we move on to the topic, I have a small request. Please don't forget to subscribe our channel. We put a lot of hard work and effort in creating these videos. If you subscribe, it will motivate us significantly. Also, the Jupyter notebook that you are using, including the codes, will be uploaded in the GitHub repository, the link for which will be provided in the description below. Now, before I start the topic, I have also a small announcement to make. On the first week of November 2023, we are starting a batch for data science aspirants. It will be a 3 months course, which will cover the fundamentals, which will cover projects and interview questions. Those who are interested can contact me. It will be a 15,000 rupees will be the cost of the course, and 5,000 will be refunded back. Um, that is in US dollar terms. $180 is the cost, and $60 will be refunded back. And students from anywhere, it will be refunded back after you have completed the course. The idea is to ensure that everyone completes the course. Uh, now, students from anywhere in the world can join, and please contact me if you're interested. Now, coming to the topic. For first part of the topic, we'll cover the basics. We'll cover the basics of the Matplotlib and how to make it, how to plot a how to create a plot when you have a list of numbers or data. So here, what I have is I have a list, two lists I have, and I want to create a line plot. Okay, so you see, I have 1, 2, 3, 4, 5, 6, 7, and I have seven values here. So these are my this is like 0, 0, 1, 1, 2, 2, and so on. And I want to create a line plot. So I use dot plot. First, I import matplotlib.pyplot as PLT. That's very important. So what this line does is this line imports the pyplot module from the matplotlib library and assigns it um, the plot. Okay, um, and then um, what I do is I put the labels. So plot.x level is x-axis, I denote it as, and y level is y-axis, I denote it as, and then show means that displays the plot. So when it displays the plot, it looks something like this. I have the x-axis, I have the y-axis, and this is like 0, 0, 1, 1, and so on. Now, one thing you see here in the plot, that is doesn't really start from zero. It should start from here. The 0 and 0 should be here. So that's one thing I want to fix. The other thing is, if I have, if I want, let's see what I want first. I want this line to start from 0, 0. It will be a straight line. X equal to y. Then if y is equal to x square, y is equal to x cube, y is equal to x4, y is equal to x5, and I want squares and circles and triangles to denote various things, right? So that's the kind of thing I'm looking for. How do I achieve it? Okay. So in order to achieve it, I create an array of values. Okay. Um, and it says that from 0 to 0.6 with a spacing of 0.01, I create a array of values. It is given by dot arrange. Okay, and then I create, so this plot dot subplots, what it does is uh, the plots dot subplots, it creates a figure and an axis. This figure is the whole plotting area, and the axis is a subplot within the figure where the data will be plotted. So, so the figure is basically going to draw out the figure, and AX um, is axis. Okay, so now, uh, So these are all subplots within the plot. Okay, the figure and the axis. Now, what I do is I do ax dot plot, and here what I give x the value of y, which is also x. Then it will be denoted by rs, which means the red squares. The label will be red square, and then I have another one which says x and y is x square. Third one y is x cube. Fourth one y is x to the power 4. Fifth one y is x to the power 5. Red square, green square, blue square, red circles, and green triangles. Right? So that's how the plotting will happen. Now in the axis I set x level. X level is x axis and y level is y axis. And then I throw up the legend. Okay. So what do we have after that? And then what does this one do? Set underscore x limit. That means within these limits, the plot will lie. Okay. And then I show the plot. So now with all that, so I am going line by line explaining as much as possible, but you will also find everything explained in details here, and more so as you go along, so that you don't have any confusion. If you download this Jupyter notebook, you can get everything out here what I have. Okay, now I want to add a grid and let user decide the location of the legend. So that means this legend can be anywhere, and that will be decided by the user. And I also want to add a grid. So how do I do it? So everything else what I was doing before that, I get an array of values for x coordinate. I create these subplots, and I create the um, markers and all that I do. Then x level and y level I provide, the limits I provide, and then the grid. This is the part where the grid part comes in. Ax dot grid equal to is in the parameter true. It essentially means that I have the grid on. Okay. And the position of the legend. So legend position is input, and enter the legend position, and then whether it is upper right, lower right, or center. So whatever value I put, accordingly the location will be, so ax dot legend function, and that will be the location, will be the legend position. So whatever value I put for the legend position, so that will be, whatever value I enter, that will be stored in the legend position variable, and the location will be the legend position. Okay. So now when I do that, I want to run this and see. So it says, okay, I want center. That's most interesting. Okay, look, I have it right at the center. Now if I want upper right, okay, I have it at upper right. Okay. So that's all I have for this part. And we move next to the multi-series line plot. Friends, uh, now moving on to this idea of multi-series line plots, what we are looking at here is we want to create a plot which will have the sine curve, the cosine curve, the sine curve, the tangent curve, and it's between 0 to 1 in the x-axis, 0 to 1 in the y-axis. So it's a plot of trigonometric functions. Okay. So in order to do that, what we plan to do is first we import the libraries NumPy as well as Matplotlib.ipynb, and then we create points between 0 and 2 pi. So how is it pi? Np.py, that is pi as a function, um, as a function of the numpy. That is going to be pi. So 0 to 2 pi, between that we want 100 points. So once we have 100 points between that, we need to normalize it. So I divide these points by, so that is stored in the x variable, um, and that's an array of values, and then I divide it by 2 pi each point, so that will be stored in x1. Okay, now the cos values, so x-axis is what? X-axis is x1, y-axis is going to be my cos values, and these cos values is like between 0 to 2 pi, right? So I need to work with x. So np dot, so cos function, which is a part of the numpy library, and that will give me my value, cos values, similarly sine values, similarly tan values. And then this plot dot subplots, that means within the plot I am creating this figure as well as axis. Now this axis dot plot x value, y value, the label. The label means I'm talking about, this is the labels, and then the color, that is cosine will have red, sine will have blue, and that's all we need. And then set the x level, which is the angle times 2 pi, and the y level, the values, and the title, the trigonometric functions, the legend, this legend pops up, and then the limits 0 to 1 on the x-axis and 0 to 1 in the y-axis, and show the plot. So whether the plot is correct or not, how do I know? So if I go to sine 0, this is sine is blue, sine 0, it is 0. If I go to sine pi by 2, which is somewhere 0.5 here, then which is no, sine pi by 2, this is pi, right? This whole thing is 2 pi, 0 to 1 is 2 pi, and then halfway it is pi, and then somewhere here it is pi by 2. So sine pi by 2 is 1. Okay, and then for the cos of 0 is 1, and cos of pi by 2 is 0, and tan 0 is 0, and tan pi by 4 we know, that means halfwhere somewhere here is 1. Okay, so that ensures that this plot is correct, and I have all the values provided here. You can have a look and verify. Okay, tan pi by 2 is undefined, and I expect this is tangent. I expect this somewhere to be undefined, right? Yeah. Okay, so now let's come to the bar plot. So for a bar plot, we are looking for something like this: two bars, right? Each representing something. So suppose I have a doctors and patients, and the number of doctors and number of patients. So I want to represent this as a bar plot. Very simple. So what I do is I use plot dot bar. The categories are the list of names, that is doctors and patients. Count is the values of these names, values related to these names, and the color, that is blue for the doctors and green for the patients. And the x level is category, the y level is count, and the title is number of doctors versus patients, and I show the plot. Okay, simple. Now I come to a little different. I have a list of names for schools, school 1, school 2, school 3, school 4, 5. Okay, and I have number of students, which is also as a list in this, um, for the students. So for 200 students are studying in school 1, 300 in school 2, thousands in school 3, and so on. Now I want to create a bar plot for schools and students, and the color should be purple, right, for the plot. So X level is the schools, Y level is the number of students, and title is number of students in different schools. And I show the plot, and it comes very nicely. Okay. Now, still in the bar plots, I want to have two plots shown side by side. Two bars shown side by side. One for boys, one for girls enrollment. So when I go to the boys enrollment, I have a list. Girls enrollment, I have a list, and I've width of the bar given as 0.4. Now I want to calculate first the position of the bars. So I go to I find the length of the schools, and arrange the length of the schools as school indices using using a dot arrange, which is a part of the NumPy library, and dot arrange function. And then what I do is the boys positions is basically school indices minus bar width divided by 2, and the girls position will be school indices plus bar width divided by 2. So that's the position now determined. Now once the position is determined, I go for the bar plot, which is boys position X, boys enrollment, which is Y, the width of the bar width, which is the width, the labels is boys, and the color is blue. Similarly for the girls. So now once that those things are there, I can label these as X level schools, Y level number of students, title enrollment of boys and girls in different schools. X ticks, this means that the school indices that I got, that it should come right here. School 1 should come right here. And what should come? Schools should come. And provide the legend and show, which means show the plot. Everything I have explained in details for you to figure out. Okay, that's all. We have one more thing on the bar plot, which we look up next. Friends, we go back to this plot. So I've shown before this plot. No, so this. So let's start with this plot, where in one plot we have both the boys and the girls. So what do you do in order to do that? You have the schools where the list of schools is provided. List of boys enrollment is provided. List of girl enrollment is provided. The bar width is 0.4. Now I want in the same bar the boys and the girls. So first I find out the school indices, length of the schools, and we arrange it, and we get the school indices. Now when I plot the bar, when I do the bar plot, the school indices is the x-axis, the boys enrollment is y-axis, level as boys, color blue. Now for the girls enrollment, x-axis is the school indices, girls enrollment is the the y values, and bottom is equal to boys enrollment. When I put that, that means the boys enrollment, the girls enrollment will be on the top, and the label is girls and color is pink. X level, Y level, title, all, and X ticks, which basically these values that you see, school 1, school 2, school 3, that you can see here, X ticks. And then legend and show, put up this plot. Now a little variation from this is if I have teachers also as well. In that case, everything else remains the same. When I plot for the teachers, school indices is the x-axis, teachers y-axis, and the bottom is an array of NumPy array of boys enrollment plus NumPy array of girls enrollment, and then you have the teachers label, color, and so on. And then you get the same thing as you were getting before, except that now you have three things represented in one plot. Okay, I come to um, now I come to something to show a scatter plot. In case of the scatter plot I'm trying to show you, I have age groups, right? You have I have a list of lists, and I have three different age groups, and there are three job changed lists, how many jobs they have changed for each of this. And then I have the scatter plots for the age groups. Is I have three colors: green, blue, and red. So I have a for loop. So, so what I'm trying to have, I'm trying to have a plot where this is one age group, this is another age group, and this is the third age group, and they will all show in terms of different colors. Okay, so uh, I have a loop, for loop. So for I in range, length of the age groups. So length of the age groups means how many. Uh, so I take the first age groups, I find out the length, and ages is basically age groups with I. And so age groups with I means it will take this one, and then job changed is job changed lists I. Okay, so it will have now separate lists it forming, and then plot it, plot scatter ages, job changed, and the colors is going to color I, which is first green. Next it goes to I is equal to one in range, and then it will go to, so I find the length, right? It should be three. So now, so first one is three. First one is uh, zero. Second one is one, and third one will be two for I, right? And so age groups two will be age groups one will be again ages and job change and everything else the same, and it will plot as blue, right? Zero, one, two for colors. Okay, so I have that one. Now I go to histogram. Histogram, I have a simple histogram to start with. Suppose you are trying to get a exam scores, which will generate as a random number, and we'll give you a seed means we first import the Matplotlib and the NumPy libraries, and random.seed means it's going to generate the same kind of same number random numbers every time I run the program. And exam scores is equal to np.random and rand integer between 50 to 100 and 100 numbers. Okay, and so I plot the histogram dot hist exam scores, which is this numbers, 10 bins, I divide it into 10 bins, and age color is black, which you see is black age color, and then give the x level, y level, title, and show, and then it should throw up this plot. Now, when I have a fitted normal distribution, means on top of this, I want a normal distribution like a Gaussian distribution to show up. Okay, so so that means it should maximize around the mean, and then it should decrease, right? So in order to do that, what I needed two things. I need first that a uh, probability distribution function. This probability distribution function, how do I have? I have it in this formula. Probability distribution function. Sigma is the standard deviation, and this part basically normalizes the values. And this part is a Gaussian, where x is the value and mu is the um, mean. And this one says that as it moves away from the mean, it decreases rapidly and maximizes at the mean. Okay. So in order to get this, first I have to get the mean using the NumPy, the standard deviation using the NumPy for the exam scores, and then the line space, which is the minimum of the exam scores and maximum exam scores, and then there's 100 points which I'm generating in between. And then I have the probability distribution function, uh, which has basically these two components. And then they do the plot, which is x, that is the my x-axis, partial the probability distribution function, which is provided here PDF. It will go as R, but this red color. Label this in label, the slash mu that you see, you will see basically. So within this curly braces, whatever we see is the value of mu, which you have already got from here, the mean, and it is 2 decimal points. And similarly, the value of standard deviation, 2 decimal points. But whatever you are seeing, the slash mu and slash sigma is basically to embed as mu and embed as sigma. And I show you what I'm talking about. If you come here, then you see that it's, you see mu and sigma, right? These values, it's coming from there. And then everything else is the same: x level, y level, title, legend, and show. And then you should get this. Okay. Now I will move next to, I'll leave out the box plot. It's a little more complicated. I'll cover that later. But next, I will move to the pair plots, and we'll go to the time series plots and the 3D plots. Stay with us, friends. See you. Friends, before we go to the next part, um, we now start with the pair plots. Okay. And for the pair plots, you need the Seaborn, the Pandas, and the Matplotlib. I had a little issue with downloading Seaborn. I had a lot of things, but eventually I could. Okay. So now, suppose you have a dictionary called data. You have car and the different names of the car given as a list. You have different mileages for these different cars, different horsepower for these different cars, and different price for these different cars. Okay. Now you first want to define a data frame as the as pandas. So pandas.data frame, and pass on the dictionary. So the data frame will be created right away, right? And then for the pair plot, which is Seaborn as SNS dot pair plot, as a as so you pass on two arguments to this method. Okay, one is DF, which is the data frame. Another is the hue, which is the car. That means that means that each point, each car will have a different color. That's what hue is equal to car means. So when you see it, you see something interesting. It goes price, horsepower, mileage, and price, mileage, price, horsepower, mileage. So what is price and price and price? Nothing, right? Mileage and mileage, nothing. Horsepower, horsepower, nothing. Rest you have all these plots for different types of cars, different brands of cars. Okay. So now we go to the next type, which is time series plot. For time series plot, apart from NumPy, Pandas, and Matplotlib, you also need date time import, date time, and time delta. Date time and time delta from the date time module. These are used to work with dates and time intervals. Okay. So let's have a start date, which is the 1st of January 2023, and the end date, which is the 31st of December 2023. And within the date range, the start is start date, end is end date, and every day is a frequency. So you create a date range between that with every day interval. Okay. Then you create a random numbers, and these random numbers will have a length of the date range, and then comes some function. This is the sum of these random numbers effectively for the for that. So this line generates a NumPy array of random numbers using the normal distribution with a length equal to the length of the date range. And this function comes sum is used to compute the cumulative sum of these random numbers, effectively creating a random walk time series data. So for each date range, you have these data values. Okay. And now when you create a data frame, the date is the date range, right? The date range, and value is the data values, and that will create the data frame. Now when you give index, so date column as the index, date column as the index means that sets the date column as the index of the data frame. You know what the index is, right? And this is typically from time series data because it allows for convenient time series indexing and pattern. So date column as the index of the data frame. And then we create a plot size with a figure 10 by 6, and the plot x-axis is the index, y-axis is the value of the data frame, right? And level is the time series data, and the next level, y level, title, legend, grid, and show, everything will be there, right? That's how the time series plot is coming. And I want to show you one more thing, the 3D plot. The 3D plot is basically uh, so I want to create a 3D plot like this. About what? About so about the um, so what I'm trying to do here first. Friends, so first let's look at the 3D plot now. In the 3D plot, this is what you're trying to do. You're trying to plot a parabolic surface in a 3D coordinate space. How do you do that? We first import the so let me show you the plot. This is what you are trying to do: create a parabolic surface in a 3D coordinate space. Let's first import the libraries: NumPy, Matplotlib, and this. What is this? MPL toolkits dot mplot 3D import access 3D. What is this? So this is basically a toolkit within Matplotlib that enables the creation of 3D plots. Okay. Then we create a data for the 3D plot. U is the so from -5 to 500 points, and again y -5, v is -5 to 500 points, and then we create a mesh grid of u and v. Okay, so once that is done, we create this surface. X is u, y is v, and z is u square plus v square. So that's the parabolic. We are defining the parabola. Um, and um, then what we do is we plot the figure, and we add a subplot, and this one is basically to subplot with projection 3D. This prepares the figure for the 3D visualization. Now to plot the 3D surface, we plot the surface with xyz, and this varieties is basically the color map used to color the surface, and then the x levels, y levels, z levels, and then the um, set boss aspect means the all the xyz have the same scale, and we set the limits of the values from -5 to 5, -5 to 5 the y limits, and the z from 0 to 50. And then the grid, put on the grid true, and then this is padding basically, and then you show the plot. So that's what you are getting. Now the another thing that we can try is a box plot. So I'll show you how to get a box plot. So what is a box plot? So you have a bunch of data scattered, and then you have uh, this box plot. On the right side of it, 75% of the data lies on data points line, and on the left side of this line, right side of this line, 25% of the data points lie. And this yellow line that you're seeing is a median. The left side of it is 50% of the data, right side of it is 50% of the data. And these are the whiskers, which is 1.5 times the quartiles, which is this is the quartile, this is the quartile. And then anything outside the whiskers is the outliers. So what we do is we first import the libraries. This random seed means that it's random points, but whenever we run the program, it will generate the same set of random points. And mp random dot normal, it means that the mean is 0, the standard deviation is 1, and so you're getting points for normal distribution, and there are 200 points. And then we stored it in data 1. Now we create a figure and a subplot, and the size of the figure is 10 and 5. 10 is the width, 5 is the height. Now figure will hold the reference of the figure itself, and x1 is a tuple hold reference to the subplots that we are creating. Now the box plot is ax1 dot box plot. The data that you have created is x. That's the parameter, and it's uh, the vertical is false means it's horizontal, and labels is group one. Show flyers is false means show flyers is false means that argument specify that you want to hide the outliers in the box plot, and patch artist is true means you want to color it, right, filled with colors. Then the box plot is customize the color of the boxes. The box plot is red. For patch color in the box plot, uh, here what we are doing is, you see zip here, and we are providing the see the box color is red. Then for patch color in zip, over pair, so this line sets up a loop to iterate over pairs of elements from two iterables simultaneously. Box plot boxes, and the list of the boxes, the box colors, right? So we zip it means we combine into two pairs, and the loop iterates over these pairs. Now the patch receives a box element from box plot boxes, and the color receives a color from the box color list, and then the zip pairs it and it iterates. Now with the for the points, ax1 dot scatter data 1 is the x value, and the y value is random normal. So this one is like creates the scatter. Okay, let me tell you what this one is. This one is uh, centered at 1. 0.04 is the standard deviation, and the size is the length of the data, which is x1. Okay, and the color is red, label is group 1, alpha 0.5 relates to the transparency, and then x level, y level, title, legend, and tight layout means that everything lies within the plot. That is, labels and everything lie, the legend, everything lies within the plot. And then show the plot. Now we can also do this for a couple of different box plot in one, in the vertical as well as the horizontal, as well as the horizontal. And I've give the details on all the processes, all the explanation of each and every line. And you can download this Jupyter notebook and can go through it. Now, regarding the announcement that we made at the beginning of the video, we are very happy to let you know that from November first week onwards, we are starting a course for data science. It's going to be a 3 months course, going to cover the basics, projects, and interview questions. And it is going to cost 15,000, but 5,000 you will get back once the course is completed. And for those outside India, it's going to cost $180, and $60 they will get back. $60 you guys will get back after you complete the course. Please let me know through email if you're interested, and we will schedule you for the upcoming batch. Don't forget to subscribe to our channel. Thanks for watching. Provide your comments and like the video. Thanks and happy learning.